All right, so before I dive into the slides, I've got a couple of questions just to sort of gauge where we are as well. How many of you folks are currently doing dual stack DNS with v4 and v6 on your servers? Okay, a little lighter than we'd like to see. And how many folks here are doing DNSSEC, either validation or signing? Okay, and is anybody actually doing anything in production yet with Do or Dot? Oh, okay, excellent. So yeah, our next talk, Casey will be talking about some interesting stuff with rollouts, so I'm looking forward to that as well. So the other part of this is I'm going to go through this relatively quickly because I'd like to have a little more time at the end for a question and answer, because the thrust of this really is there's been a lot of misinformation for the entire life of DNS of what it does and does not do and what isn't hard. And that is mildly interesting, but more interesting when it gets to the what can you do about it, or what does that mean for you when you're actually rolling it out. So I'd really like to get you guys feeding me back some of, questions, experiences, whatever. I have been doing DNS in large scale since about 1990. I did start reading the RFCs and looking at the stuff back in 85 or 86, and at the time I was sort of amazed. I'm now even more amazed that it's survived through this. So let's start sort of with how did things start way back in the dark ages. And in those days, obviously, everything was bare metal, and it was, in some cases, mini and mainframes. 56K links were pretty fat pipes. Everything in hardware was expensive. So preserving RAM, preserving disk, being very conservative of what you sent over the wire were all things that were far more important than speedy performance. It was also in the days where we knew each other. If something broke, we usually actually had a phone number, or we could finger the host and get their office number and call them back and say, hey, you did something bad here, can you fix that for me? In those days also, you could actually read the DNS RFCs in a weekend. It was kind of a dull read, but you could actually get through all of them. Bert Hubert's DNS Camel, the last numbers I saw from that, we are now at 185 RFCs that are still current and 2,800 pages of specification if you, in theory, want to absorb it all and make sure that your implementation is RFC compliant. Woohoo! Everything was unicast. Anycast was not even a bad trick in those days, and it was pretty much all UDP. We knew that TCP might be useful at some point in time, but again, it was considered slower and more expensive of resources than any of us wanted to cope with. And in those days, if you had a security checklist, they probably weren't even thinking about TCP, IP, much less DNS, and they certainly didn't actually talk to anybody who was doing DNS. So in the list of things that have been wrong or never true, one of the ones that started way back at the very beginning and we have still not squished is TCP. Everyone in the world, of course, knows that TCP is only for zone transfers and is never used for anything else whatsoever, and DNS is all UDP. And there are best practice checklists floating out there that will tell you this to this day. And I've even hit stuff relating to this with PCI compliance and ACL lists. And of course, the Earth is flat. And yes, if you are unfortunate enough to encounter one of these people that at some point managed to get a decoder ring and a security audit checklist out of their box of cereal some morning and decided to declare themselves a security expert, yeah, we can try and see if we can hopefully correct that. Obviously, with the large packets that we are starting to see these days, eDNS 0 is helping, and we have extended the life and utility of UDP. But there are still times where setting the truncate bit and sending over TCP is the correct answer. And so there are a lot of reasons why, and we'll talk a little bit more also about some of the DNS over HTTPS and DNS over TLS, where those of us who have mostly tuned kernels for UDP for many, many, many years are going to be getting to talk to our web folks and getting recommendations on how they got their servers to survive the HTTPS everywhere challenge. And so there are good reasons for doing this other than just AXFR and IXFR. We have overloaded everything in text records for years. I have also seen people who do really cheap load balancing by hoping to do round robin and putting 20A records out for a particular label. I've seen all sorts of spectacular things in my experience in DNS where it's awfully easy to get over a 1280 or 1500 byte packet. And unfortunately with IPv6, in general, fragmentation has been a problem. And while I'm not a fan of we should drop every fragment because it's too easy to spoof and poison caches, and DNS and fragmentation should not mix. In reality, we need to be able to deal with it if we're going to ever get rid of v4 sometime in the next 40 or 50 years. And there's some things that we're starting to do with TCP that are actually of use. Pipelining and being able to eat the overhead of doing the TCP once getting multiple DNS answers in the same packet, or nailing up connections between particularly busy eyeball recursive servers and very popular domains, the Facebooks and Twitters and various other things of the world that love having 200 DNS lookups for every web page. There's a lot of advantages to that. And also in today's world, the whole, oh, well, you can't do that with DNS and you can't load balance because TCP will break if you're not getting to the same host every time. And the reality is that load balancers also have gotten modern hardware, modern software. There are interesting techniques with hashing and sharding that allow you to much more consistently hit the same servers. There's also a very good RFC on stateful DNS and why having state isn't necessarily broken for DNS. IPv6, which is one of the other things that I have spent a lot of time working on, has unfortunately done themselves some disservices. I love the fact that intermediate boxes are not making decisions about dropping packets based on size. Unfortunately, also in the serial box level quality best practices, the whole ICMP is evil and should be blocked is a problem when v6 is signaling stuff like, I dropped your packet because it's too big and you should resend it in a smaller size, because only the sender can actually refragment at a smaller size. The folks at APNIC, Jeff Houston and George Michelson and João Adamas have been doing some very depressing research in what happens with fragments and how robust that is. And I've seen numbers in terms of drops or failure to get the actual payload in double digits, 15, 20%, with a lot of common stacks. It's getting better as more people are upgrading and v6 is more mature. But the reality is that fragmentation is dangerous and not reliable. One of the other things that they also did some research on is what happens, how many client stacks with stub resolvers or with recursive resolvers in cheap CPU routers will actually retry with TCP if you truncate and set the TC bit. And that's also a depressingly high number, where I think somewhere in the 80-ish% success rate, which Bs are okay, but we kind of like to see a few more As in the class. So, DNSSEC. Just a couple things about DNSSEC first before we dive into what is and is not valid, useful, and true. DNSSEC is basically using public key or asymmetric encryption, which means that there's a public key which is published in the DNS and a private key that is held closely by whatever is doing signing. Public key encryption can do two things. You can use it to encrypt so that only people who have the other half of your pair can decrypt a file and read it. But the other thing you can do is create a digital signature, where by using those keys, you can validate that someone has not changed whatever it is that signature is for. And DNSSEC signs RR sets, the resource record sets in DNS, and supplies the keys so that you can walk the chain of validation and you can verify that what was put into the zone file is exactly what you're getting from your recursive resolver or your stub resolver once it's validated. It is not magic. If I put something stupid or wrong into my zone file and sign it, you'll be able to validate that you got exactly what mistake I put in. But at least you know that no one in the middle of all of that has monkeyed with the results. And basically, unfortunately, because we wanted to be backwardly compatible, all failures are serve fails. So something went other than perfectly correct is what serve fail means. And there's no idea of what else might happen. There is a draft for extended error codes in the DNS op working group that is dangerously close to getting through. And that's where we have attempted to actually give something more meaningful than it all didn't go perfectly. And we'll be able to actually see that it was a network or a DNSSEC validation or some other failure, and be able to hopefully do something more useful in our applications. So, DNSSEC. The biggest problem is that when it rolled out way back when, the folks that wrote the software were all protocol wizards and hardcore DNS people that felt that anything more user-friendly than VI or Emacs was a waste of their time. And that was their idea of the epitome of a UX. So signing and keys and key rollovers and key management were all spectacularly hard. About 10 years ago, when I was working at ISC and doing training in DNSSEC, we spent an entire 8-hour day walking them through the process of how to manually create keys, sign the zone, and get the signed zone to be served. So shockingly enough, DNS got this reputation of being really hard to do. And because if you did anything at all wrong, DNS just broke, but if you didn't do DNSSEC, it worked. It was decided that, boy, that's fragile and complicated. It's going to drive up our support costs. We're going to get calls. Our competitors who don't do DNSSEC signing will not get those same support calls. And what it fixed didn't seem to be sufficiently valuable to risk that kind of chaos and support burden. 10 years ago, that was a fair assessment. But we use other stuff that is crusty and nasty and fragile. I love doing BGP. I love keeping my web server up and running and functional under load. That's all trivial stuff, right? Just kind of works out of the box. Yeah, server software has gotten much better. The open source folks have all come up with tools and signing stuff that is much more turnkey. These days, you can add a zone in NSD or in bind or in not, have 4 or 5 lines of config file, reload the zone, and other than the fun of getting your DS records up into the parent, if it's not done by the same folks that are running your zone, it just works, and it continues to work. There's also the fact that at this point, a lot more large-scale deployment of both resolvers and validation and signing. So it's not just a bunch of IETF wonks, sitting in whatever room they're in doing it. We actually have very large companies with hundreds and thousands of employees who are all now familiar. I can actually put out that I want DNSSEC background in a job hunt, and I'll get candidates who all say, oh yeah, and who have done real work. And on the public side, the Quad X servers, Quad 8, Quad 9, Quad 1, people like Comcast are all doing validation and have for years now. And I just confirmed the latest numbers. I had worked at Comcast redoing their recursive infrastructure. They do 600 billion queries a day. And they are now about half the size of Google's traffic. And just those two alone are well over 1 trillion. And the DNSSEC validation failures that actually get up to a DNS engineer and require something to be done are in terms of single-digit dozens per month. And it's I wasn't really good in science, but I know with the scientific notation version, we're like, -12, -15, something like that in terms of error rates. I can also tell you that Google and Comcast both have engineering managers who, if there were support calls that were driving up their support costs dramatically, would be revisiting this. So these days, you can pretty much say that it is really robust. The software is ready. You can get real stuff done with it. You can find expertise. So the "it's too hard" argument has mostly gone away, at least as much as any other protocol we use. You can say the same thing. And there are benefits. Cache poisoning is still relatively trivially easy to do. Post Kaminsky in 2008, we did discover some things with randomness and entropy and various other things. And at least we're not at the birthday attack where at 500 to 600 packets, you have a really good chance of colliding and polluting the cache. But A, there are still enough people that run crusty old stuff. And B, we slowed it down and made it harder so that it's in terms of hours, not minutes. But if you're determined and you've got the right root toolkits and stuff, you can still dump stuff into cache. And DNS hijacking, which is very prevalent and very rewarding, and there are several state actors who are actively doing this now. This is one more thing that makes it easier for them to go through. When the DNS espionage stuff was happening and PCH got cracked, part of why they did was their mail server was exposed, but the MX and A were in DNSSEC. However, they had 2 employees with Apple phones who were behind hotel firewalls that would not allow them to use their own DNS servers and did not DNSSEC validate. And so they were able to spoof and lie, and those folks didn't catch it. And the phones connected before they could come up with any VPN or do anything else secure, which meant that they leaked their email credentials. And once they had their email credentials, daisy chain, hop through, get some emails, read some stuff, get into IMAP, find a few things, and see whether the passwords work elsewhere, and there they were. So DNSSEC will slow that down. DANE is becoming not as prevalent as we'd like. There are a few places like Germany that are now making it mandatory, but it is not as uncommon as it once was. We're doing other certificates. It's better protection for CAAs. Folks like Let's Encrypt are actually checking whether your zone is DNSSEC signed, and you will have better protection and cleaner automation if you're actually doing DNSSEC. And last and sadly not least, like I said, I've been doing this stuff since '84. We have had 2 successful wide-scale deployments of PKIs in existence. One of them was the Kerberos that wound up hiding under the hood for Active Directory that Microsoft has been shoveling for years. And the other is DNSSEC. We have not, correct me if I'm wrong, and I'd love to talk to you after my chat, but there have certainly been other attempts, but nobody else has actually gotten to an internet-wide deployment of a useful and secure PKI. So let's use it. So, okay, so it's useful, but what does it actually solve? Basic security, this is sort of the triangle. Confidentiality. Nobody who's not supposed to see it should be able to see it in transit or at either end. Integrity. Did what I receive match what was originally sent? And availability, when I need that information, can I get it? So DNSSEC really mostly just solves one problem, integrity. What I put into a zone file and sign, anybody else who validates will be able to say, yes, this is what Paul stuck in his zone file. This must be what he meant for me to have. It means that people can't get into my registry account, change my name servers, and set up false name servers unless they remembered to delete the DS record in my registry account, which fortunately the bad guys don't always remember to do. And with 24 or 48-hour cache, there's still a window in which I can notice that my name servers have changed. So it protects me from false name servers. It protects me from cache poisoning. And again, those are not complete solutions, but these days, it is all about defense in layers. You know, anything you can lock down and make more secure is worth doing if it is not ridiculously onerous to do. And the other side, okay, fair enough. You know, we're talking about myths and legends. What doesn't it do? Well, it doesn't do confidentiality. It still goes in the clear. It just goes in the clear with signatures for validating. I can still overwhelm your authoritative server or a transit point and make you unable to be able to get an answer from my authoritative servers. It does not protect me from putting stupid stuff in and making mistakes or having script failures in generating my zone file, sadly. And it doesn't help with the parent. Your parent still also has to be secure. And of course, for DNSSEC, they also have to themselves be signed and verifiable, or there's not a clean chain. So, if this doesn't work for confidentiality, we're now also in the post-Snowden era. There are state actors who are interested, and there are repressive regimes that are interested in spying on us. There are allegedly democratic regimes that are interested in spying on us. There are commercial entities that want to spy on us and give us targeted ads, sell our data, correlate us, identify us, track us, and anything that we can do to at least slow down the leakage of who we are, what we're doing, and what we're interested in. The IETF several years ago said, that's important and that's worthwhile work. So there's an RFC that basically says, in the face of pervasive monitoring, we should encrypt anything that we possibly can. And these days, most of the pieces of the internet, from the Wi-Fi that someone can ward drive and camp onto, all the way through our providers, the websites we see, our employers, and all the rest, they are watching. We already know that. So there were two efforts. The first attempt with DNS said, let's at least encrypt from the stub resolver to the recursive resolver, because that's where the most dangerous leakage is. Because that, if I can get to the stub resolver, I can get to the home IP address. I can now tie it to at least a home and possibly even to a device. And that's very definitely PII. Comcast, knowing that 6 million homes are interested in resolving www.facebook.com, is not PII. And that's much less of a disclosure. So there is software that was out there for years, DNS Curve, done by DJB, that tried to solve that problem of the how do I get from my stub resolver on my operating system to my recursive resolver and encrypt it. That really never got adopted widely, though the algorithm that we now use, ECDSA, is also elliptic curve. And so DJB at least gets the credit for getting our attention that elliptic curve was a pretty cool algorithm. It's relatively cheap computationally, and it generates much smaller signatures than RSA and DSA. So that was a good thing. So we're already using TLS, and if we go with the everyone should support TCP as a DNS server, because it's in the RFC and always has been, then TLS is just a TLS handshake. And as a matter of fact, if I'm recalling correctly, Unbound's initial patch that someone submitted for making DOT work on Unbound was on order of 12 lines of C code, something like that, because most of the logic was already in there. So that was a fairly straightforward one. The downside was that it comes to a well-known port. And so if you decide you don't want that, you simply block that port and DOT breaks. And while you can, of course, run it over a different port, or you can even run UDP 53 on a different port. I have certainly run a name server on port 443 before that had nothing to do with HTTPS because it works great at hotels. It at least was a part of the problem, and it was cheap and it was fast. What then happened, though, was Mozilla got into the game and said, well, we have this piece of software that kind of knows what to do with HTTPS, and we kind of like it. And for us, there's really not much more overhead than TLS to do that. And there are a couple of other cute tricks we might be able to do. And they came to the IETF and worked with some other folks. And within about a year, we had DNS over HTTPS, for better or worse. It does solve confidentiality for a point-to-point link. Obviously, again, it doesn't deal with the recursive to authoritative part of the path. And there is work in the IETF on what it's been called ADOT, which is authoritative, i.e. DOT from the recursive server to the authoritative server. And there are some trade-offs there as well. But at least the PII leakage of my house or my laptop or whatever, and what I'm asking my recursive resolver for now can't be sniffed. However, it does not solve the end-to-end data integrity problem. It is a point-to-point confidentiality. And so another in the myths that several people have gone through is, oh, we don't need DNSSEC anymore because we have DOE and DOT. And it's, no, they are a different problem and we need both. And we should use both. It shouldn't be a choice of one or the other. They both have advantages and usability. And then obviously availability is the same. It's, DDoS will take out name servers, and it doesn't matter whether it's encrypted or not. If you can't get a packet, you will not get an answer. So a little bit about what several folks are doing in major initiatives. The one that really started the flurry and the gloom and doom of DOE is evil and oh my God, the world is ending, was Mozilla. Because they did two things that upset people that were not necessary or part of the protocol. They are an implementation choice. And the two things they did, one of them was it was opt-out, knowing that 95% of all users will never touch anything that is not the default. And so basically they guaranteed that everybody using Firefox with that release was going to be switching to DOE. And the second piece was they decided for us who that was going to be. And they went with Cloudflare. And of course, Europe said, you are now bypassing my ISP that in Europe, we don't hate nearly as much as the US hates their ISPs. Because A, they've had a better relationship, B, they have GDPR for privacy and violations. But now you're shipping it off to the US where a US warrant will expose my data without any GDPR protections whatsoever. Also scary is that it completely bypasses everything in the OS. So enterprises all said, oh my God, we have group policies and AD and all of this stuff to make sure that our users don't do anything bad with their browser and with their DNS. And we have filtered DNS that works for us. We like being able to block malware and botnet and command and control and all the rest of it. We feel that that's a good thing. And so that was the one that sort of got this to be so controversial. They have somewhat slowed down. One of them is they are now working feverishly to abide by group policy. This does not help small and medium businesses where there is no IT staff and they have 6 people and they're all running Windows, but they're running them as unsecured with no AD, unfortunately. And for large ISPs and other folks, they have what's being called a canary domain. Firefox will fire up and it will check this domain, and if it gets an answer, it will go, oh, you don't want us to use DOE, I will turn it back off. We'll see if they somewhat more soften their stance. The next two, I think, did a more nuanced and incremental upgrade, and I think that that's probably a better path, and hopefully Mozilla will start going through. Google originally also was like, oh, we're going to put it in Chrome and we're going to throw it out in release, and then we're going to turn it on in, I think it was October of last year. And the world said, Google's even more evil than Mozilla and Cloudflare. This is horrible. And then, of course, the Wall Street Journal started blaming them, and they were somewhat surprised, and they sort of went, oh, okay. So the first thing they did was they said, let's make it opt-in. If you don't turn it on, you don't get it. And then they said also, we don't mind DOT. We were already supporting DOT in Android. So we're just going to do an auto-discover ourselves. There's no RFC for how to auto-discover what protocol support there is with your recursive server, what encryption, if any, it will support. But they say, hey, we'll just do what's been done. DHCP and or RAs will tell us what our DNS servers are, and we'll get IP addresses, and we'll just try it. And if DOE works, we'll switch to doing DOE. And if DOT works, we'll switch to using DOT. And if not, we'll do it in the clear. And I think that incrementally is a much more sane way of doing it. And it's somewhat less of a surprise to everyone involved. Microsoft also, one of the other objections was, I can control the OS, but this application isn't following the rules. So Microsoft said, well, okay, we also think encryption and privacy is a good thing, and we think that having that option for our customers is something that they should be able to do. But they should be able to do it for everything. In one place, with a dialog box that turns it on or off, in the same section with the privacy settings that they already have for other things, and their version of Chrome will just follow the rules. So they are doing opportunistic DOE as well. They will see if it's available, and they will have some lists also short-term of trusted providers. And then the stub resolver in the OS will just use it. So if you are in a company enterprise network ISP and you either don't want to lose access to the DNS data for debugging or troubleshooting purposes or security purposes, if you don't want to lose the ability to give customers filtered feed when they opt in, parental controls, malware blocking, the rest of it, or if you simply are at a place where you want to be able to catch DNS exfiltration and tunneling over DNS, the odds are what you should really be doing is most draconianly, obviously for Mozilla, set up the canary domain in your DNS servers. And for everything else, simply enable DOT and DOE on the same IP addresses you're already handing out for traditional. I would make the case that encrypted within the enterprise and visible only by IT who has access to the DNS server is a feature anyway. I do SSH tunnels in my home and don't trust that my network is in any way safe or clear. And I think that an awful lot of security professionals would do the same. All right, so that's sort of the landscape. What I'd like to do now is get feedback and questions from you guys. Yeah, and so there are microphones there and there. That way they can get it into the recording. They're right behind you. Yeah, and the normal NANOG, state who you are.
David Belson with ISOC. For Chrome, for Google, is the DOE enablement or the DOE checking, is that only in Android or is that also in Chrome for macOS and Windows?
Currently, my understanding is that is Android only.
Okay. That would make,
and
given
at the
description,
OS.
that makes sense.
Right. Currently, the browser is going to be doing just DOE.
Hi, Brian Fields, Nokia. So my question about DOE, sorry, the echo is messing with my head. My question about DOE is, doesn't that just move the potential for, like, instead of my ISP being able to essentially spy on me, doesn't it just move it to, like, Cloudflare or somebody? So does that really solve the problem? I mean, I understand we trust Cloudflare maybe more than Comcast, but, you know, there's a lot of companies that started out and said, well, we're not going to be evil, and they're a little evil now.
Yes, indeed. And yes, it's essentially who do you distrust will inform your choice. Because there's presumably someone you are more scared of having access to that data. I think these days the reality is even with the trusted resolver, the TRR that Mozilla is doing and that Cloudflare has contractually agreed to of the, we won't resell it, we'll throw it out after 24 hours, all the rest of it, but they still look at it for 24 hours. And we are in a state where Amazon probably knows more about me than any friend or relative does, just due to my Amazon purchasing habits and browsing habits. And so to some degree, we have long since lost our ability to truly have privacy. So what it really boils down to, what is the most egregious thing to you? So if government surveillance is it, I think you're really screwed, and a VPN is probably a much more usable solution than merely DNS anyway. But if what you're more concerned about is just feeding the ad maw that we are creating and the ad capitalism that we have unfortunately allowed to flourish, this at least slows it down and makes it more painful and more expensive. So yeah, much in the same way that we only get to vote for whoever managed to get through the primaries, we don't really get to vote for who we actually want. Yeah.
Hi, Tail. Actually, kind of surprised. So, IETF co-chair the DOE working group. One of the things I'm surprised that Paul said I'm not surprised he said it the first time, but I'm surprised he didn't just emphasize it again in his answer, is there's nothing in the DOE specification that says you have to have centralized DNS.
Correct.
This was a major issue with the Firefox deployment because this was a design decision that they made to take this particular tactic. And there are in fact many other DOE deployments, including within major telecoms and ISPs, to have a local DOE resolver that is effectively no different than using their current DNS resolver, except now there's an encrypted channel within their network to that resolver.
Yes, thank you. And that's why I repeated several times about why I thought that the Google and Microsoft approach, which is you're not changing who you have the relationship with, you're merely changing the transport, is a much better incremental step.
And as a follow-on to that, the IETF is currently in the process of trying to charter a new working group, the Adaptive DNS Discovery Working Group, where we will be co-chairing, presumably, once the ISG approves it, where it is one of the main work products that's intended from the working group is that we will have a client resolver, a client itself will be better able to understand the resolver environment that it's in and make an informed choice about the kind of resolver it wants to talk to, which would possibly be talking to a centralized DOE server, but could also then presumably be talking to local encrypted servers, for example.
Yes, and in the slide deck in the further reading, here are the current active working or mailing list groups dealing with all of this. And we are very actively adding things as well.
A small correction to that, however. EDI is not a ITF activity.
That is correct.
EDDI is a separate independent activity. In fact, Good Straight Man is what I came up here to say, that there's an initiative for encrypted deployment initiative of how to get it right. If you go to encrypted dash, and I know we hate dashes in names.
But yes, the hot link on EDI will take you to that website and allow you to do the mailing list and the rest.
Right, and so if you're interested, I'm Glenn Dean from Comcast. This was an initiative that we pulled together, but it's made up of a lot of participants from across the industry. The goal of EDI is to bring together a community of people who are interested in successfully deploying encrypted DNS, whether it's DO or DOT, we don't play favorites, and do it successfully without breaking all the uses of DNS, some of which Paul talked about already, and they go deep. And we've been clever for 30 years in using the DNS, and the goal here now is to deploy encrypted DNS without breaking all that stuff.
Yes.
So if you'd like to be a part of that, go to that website, sign up. It's free, it's open, it's public. We would very much welcome participation.
Yes, and some of the follow-ons with that, the odds of having DNS over quick and other transport are likely and are certainly going to as well be addressed in this particular initiative.
So I am a DNS user, not a DNS administrator. And you mentioned a couple of times that Android tends to do things differently. I was wondering if you could expound upon that a little bit.
So your phone, just like any other device, uses both router advertisements in v6 and DHCP in possibly v6 and certainly in v4 to get its address, its gateway, and who its DNS servers are. What Android does is once it gets that DNS server address, it will then see whether that IP address works with DOT. And if it does, it will use DOT for all of its DNS queries. If it does not, it will fall back to traditional unencrypted UDP. And yeah, so it's very interesting. If you stand up a DOT server, you will instantly know how many Android devices you have, because that's suddenly how many new clients you have using that particular port. Other questions, comments? All right, so yeah, there are some further reading things. Yes, I did IETF and email lists. I should have made it more obvious that they were separate things. Sorry, Glenn. But yes, these are all the places where stuff is starting, and as more things spin out, if you're on those mailing lists, you will have already heard about some of those. There's another initiative that Steve Crocker is pushing, DNSSEC provisioning, which is the how are we going to potentially automate getting DSs into the parent in a more consistent fashion. All of those are mentioned in these mailing lists. And then, yeah, some other RFCs and drafts that I think that if you're trying to figure out what the space is, they're worth a read as well. All right, and if that's it, then let's see what Casey has to say. And thank you very much.